Hey, what is up guys? Welcome back to the channel and welcome to another video in the new series that I'm calling Fun Algorithms for Swift. Now, the last video we kind of had a little bit of fun implementing the FizzBuzz algorithm, and so for today I'm going to do another one, and it's going to be the problem of solving binary search. So the idea behind searching is that you want to search as efficient as possible. And this is also a typical programming interview question as well. So this is how it's typically phrased. Given an array of integers, you want to search through this array, and you also want to return true if you find this search value inside of this array. Otherwise, you return false. Cool, got it. Now let's go ahead and implement kind of a easy solution, and then we'll actually implement the binary search solution inside of Xcode's playgrounds. So let's go ahead and go into Xcode here and get started with a playground. I'm going to call it binary search, like so. Enter, save it somewhere in your hard drive. That way you can access it if you need to do so. I'm just going to give myself a little bit more space. All right, cool. Now inside of playgrounds, you can pretty much type anything out, and it's actually going to execute the bit of code automatically like that. So click on this little icon on the top right, you get this debug area that gives you a little bit more detail of what's kind of going on inside of your program. Now I'm going to kind of illustrate an example here first by creating an array of numbers called numbers, and I'm just going to put a couple of numbers in here. And let's see, 9, 11, 13, pretty much random at this point. Let's see, 20, and I think we're good. So 20, yep. That looks like a good amount of numbers. And the first thing I want to do is to actually perform a kind of naive approach to the search. And it's going to be called linear search for search value right here. And the search value is an integer. And the thing that we want to search from is this array right here, and it's an array of integers. This function will return a Boolean value, and I want to pretty much do this right here. Print linear search for search value, let's say 1 inside of this numbers array. And the idea is we want to return a value of true inside of this array whenever we get this value of 1. Otherwise, return a value of false if we're searching for something that's not inside of that array. The very simple solution here is to just loop through this array variable by doing for num in array, and if num is equal to search value, return true like so. Otherwise, we've exhausted this array of numbers and we weren't able to find it, so we just return false. So let's verify that. If we search for the value of 5 inside of this array, we actually return false, which looks good. Pretty straightforward. I hope you kind of understood how that works. Now, the interesting thing about this algorithm is actually the fact that it performs this iteration n times. So n is the amount of elements inside of this array. Basically, it's roughly, let's see, 5, 6, 5. So basically 11 elements inside of this array. So this function executes 11 times, or basically it loops 11 times to actually perform the search. Now, what if I were to tell you that there's a better way to search for a value inside of an array that is sorted from, let's say, ascending order like this? Now, if the array is indeed sorted, we can perform something called binary search inside of that array. So let me just type out the function name right here, binary search for value, search value of an int, and an array just like what we had before returns a Boolean value. And I want to do this print binary search business, and let's just search for perhaps 4 inside of this numbers array. And the idea is it should basically return a true value if we are searching for something that's inside the array. So pretty straightforward. And I want to actually, let's see, move this out of there, put that down here. Now I have some area up here to work on this binary search function. Cool. All right, so what is binary search? So the idea behind binary search, obviously binary means 2, and we basically divide this array in 2, and then we search for values in here or values in here if we cannot find the value in the middle equaling this search value. So for example, if we're trying to search for the value of 4, we first look at the middle value inside of this entire array. And if 4 is not 9, which is true, we look at the left side of this array. And then we kind of look for the middle value again. And in this case, the middle value of this entire array is 4, and we'll just return true. And then we do something very similar to the right side of the array if the search value is greater than the middle value of 9. Okay. So I know that might sound pretty confusing to some of you that have not seen this method or this strategy before. So let me just implement it and then give you a couple of print statements to show you exactly what is going on. All right, now we need to actually set a couple of variables up here, and left index and right index. Let's see, right index equals array.count -1. Basically, it is the 0th index and then the last index of that array. And I'm going to create a while loop here. While left index is lesser than or equal to right index, like this, we're going to do some checking in here. And then we're going to decide which half we are going to go into to perform the search. All right, so let's just make this example a little bit easier and search for the value of 9 inside of this array. And I'm going to do this. First, I'm going to declare a variable called middle index, and I'm going to look for this 9 value in there. So middle index will be left index plus right index divided by 2, and let middle value equals array middle index, like that. And then let's just do this. If middle value is equal to what we're searching for, which is search value, return true like so. And now if we kind of comment out this bit of code with the linear search, we see that this binary search for value right here returns a value of true because middle index in this case is actually I think it's 5, and then this array at 5 is 9, and we're searching for 9, hence we return true. Okay, that's all fine and dandy, but what if we are searching for the value of 4 inside of this array? And basically, we will determine that 4 is less than this value in the middle, and then we'll search this branch of the array. So we do that by writing an if statement. If let's see, search value is less than middle value, we actually change this right index to be this 8 value, or the 4th index inside of the array, or inside of this while loop. So let's do right index equals middle index -1, like that. And then now let's just look at this true value here. So basically we're searching for 4, and then this binary search was actually able to find it when we change right index to 4 right here. It goes and executes this loop one more time, and then middle index is actually in this case 2, and then middle value is 4, and then we get this true return value right here. So let me just print out a very, very nice print statement here just to illustrate what is going on. Okay, so let's first print out what middle value is. So middle value is this middle value here, and if we take a look at that, 9 and 4 looks good. And we print out a couple of other values right here. So left index is left index, and right index is right index right here. And then we take a look at this interesting array bracket, which I'm just going to type out right here. Array left index like that, comma, array let's see, right index like that. And then we should be good. So at the very beginning, the very first loop inside of this function here, we get left index is 0, right index is 10, and then the middle value is 9 right there. And we are searching through the entire array of from 1 to 20. And then it decides to loop again based on this if check. And then we are searching for the 4 again, and then the middle value is 4. And then we are actually looking at this array from 1 to 8 here. That's how we find this middle value of 4. So hopefully that is not too confusing. So the next question is, what happens if we are searching inside of this branch of the array? So basically, the question is, what happens when we try to search for 16? And the debugger actually goes crazy, and basically we're encountering an infinite loop that this while loop is executing. So we fix that by actually doing an if right here. If search value is greater than this middle value here, we actually set the left index to middle index plus 1. Okay, now if you take a look at this print statement now, we're doing the exact same search in the beginning through the entire array, but in this case, it's falling into the search value greater than middle value. So basically 16 is greater than this middle value of 9. And then it goes up and executes this loop one more time. And middle value is 16 in this case of 11 through 20 here. And then the, let's see, middle index is roughly 8 or 9, which gives you the 16. And then we return true because middle value is equal to the search value. Okay, let's do something a little bit more interesting and try to search for something that gives us more than 2 loops. So let's do 17 like this. And then you get this more interesting bit right here, which gives you the 17 on the third iteration of the loop. And you get 17. And that's pretty much what happens. So let's see if it returns a true for 18. All right, it executes this loop 4 times and returns a false in the case of not being able to find 18. And basically left index is no longer lesser than or equal to right index, and it executes a return false at the very end. And all that logic is being handled through these couple lines of code. Cool. Now the final thing I want to illustrate is that if we have 1,000 or perhaps 100 numbers like this, so let's make it an int like this, and let's do a for loop. I is in 1 to 100, and 100 will just append this I value right there. And if we search through this 100 array and try to search for this 18 value, notice how it only iterated through the while loop roughly exactly 4 times actually, and we were able to determine if the value of 18 is inside of the array. So let's search for something a little bit more interesting, like 99. And you notice how it went through this loop, let's see, 6 times, and it just returns true. So this is basically executing the function log n times. So when I say log, I mean this function here. So look at this picture. The linear search actually performs really, really slow as the number of elements increase, and log of n is actually this red function. And notice how it is only performing like roughly half of what the linear search does. And there's a very small area right here where they intersect, and anywhere before the intersection, the binary search is actually slower than the linear search. So that's the idea behind binary search. Essentially, you're going through half of the array each iteration of the loop, and that means if you have like 1,000 elements inside your array, you just go through 500, then 250, and then 125, and basically that goes on, and you can determine if the value is inside the array rather quickly. All right, hopefully not too confusing. Make sure to like the video if you do. I'm going to include a link to the source code inside of the description down below. And also subscribe to the channel if you want to see the next video on algorithms in Swift. All right, enjoy your night, enjoy your day, and goodbye.